Okay, uh, continuing on, Unit 4, Lesson 9, we're going to do Problem 3. Here we have a situation. A good rule of thumb for a safe angle to use when leaning a ladder is the angle formed by your body when you stand on the ground and hold your arms out parallel to the ground. So my arms are parallel to the ground. First question is, what are the angles in the triangle formed by your body and the ladder? And for this question, what I did is I used my wife as an example, and I measured from the ground to her shoulder and found it was 54 inches. And then I measured from her shoulder to her fingertips and found that it was 29 inches. And now we want to find the acute angles in this right triangle. So first, this angle on the bottom, we'll call it angle theta. I see that I have the 29 inches is the side opposite theta, and the 54 inches is the side adjacent to theta. And I know that the tangent of that angle theta is going to be the length of the opposite, which is 29 inches, divided by the length of the side adjacent, which is 54 inches. Now to solve this, I have to apply the arctangent to both sides. Remember that the arctangent cancels that tangent to get my angle theta by itself, and theta is going to be whatever the arctangent of 29 over 54 is. So I go to my calculator and I find the arctangent of 29 over 54, and I get 28 degrees. So this angle theta is 28 degrees. Now to find my other angle, we'll call it angle alpha. I remember that the acute angles in any right triangle must be complementary, so then the angle alpha must be whatever 90 minus 28 is. So my angle alpha must be 62 degrees. Let's write it down here where you can see it. 62 degrees. Perfect. Moving on to number 2. Number 2 says, what are the angles in the triangle formed by the ladder, the ground, and the railing? So the ladder, the ground, and then the railing. So we want these angles. Now this is where it was really important for us to be told that the arms up here, her arms, are parallel to the ground. If her arms are parallel to the ground, then I know that this angle between the ground and the ladder is alternate interior to the angle between her arms and the ladder. So this angle must also be alpha, which is 62 degrees. And that means that this other angle at the top must be theta, and theta is still 28 degrees. Beautiful. So now we can move on to number 3. Number 3 says I have a 13-foot long ladder and I need to climb a 12-foot tall roof. I'm going to put the top of the ladder at the top of the wall. So the wall is 12 foot and my ladder is 13 feet. I want to know, what is the angle formed between the ladder and the ground? The ladder and the ground, and we'll call this angle beta. Well, looking at angle beta, I know that the 12 feet is opposite beta, and the 13 feet is the hypotenuse of this right triangle. And I remember that the sine of that angle beta is going to be the length of the opposite divided by the length of the hypotenuse. To get rid of this sine, I'm going to do the same thing, only this time I'm going to use arc sine, because arc sine cancels the sine, and I get angle beta is going to be whatever the arc sine of 12/13 is. So I come to my calculator, I do arcsine 12/13, and I get 67 degrees. Okay, part B. Is it possible to adjust the ladder to a safe angle? If so, give someone instructions to do so. If not, explain why not. So notice I have a 67 degree angle here. I want that angle to be 62 degrees. So let's take a look in a perfect world. In a perfect world, what will the length of that leg need to be? So in a perfect world, I have a 12-foot wall. I want to lean the ladder, which is 13, and I want to figure out what is that side length. So I recognize I can do the Pythagorean theorem. The Pythagorean theorem says that the sum of the squares of the legs of any right triangle is equal to the square of the hypotenuse. So then x squared plus 144 is going to be equal to 169. Subtract 144 from both sides, and I get x squared is equal to 25. My x value is 5. Now, that's if this angle is still beta 67 degrees. Okay? What we want to do, this is the situation that I'm actually in. What I'd like to do is I would like to figure out what will that length be if my angle is a safe angle. And remember, that safe angle was alpha from above, which is 62 degrees. I still have a 12-foot high wall. Now I want to know, what is this leg going to be to give me that 62 degree angle? So I see that the tangent of that 62 degree angle is equal to the opposite, which is 12, divided by the adjacent, which is x. Now I have a variable and a fraction. I get rid of the fraction with the variable by multiplying both sides by the denominator. So x times the tangent of 62 is going to be equal to 12. Now I'm going to divide by this tangent 62, because tangent 62, remember, is just a number. So I'm getting x by itself, and that's going to be whatever 12 divided by the tangent of 62 is. I can go to my calculator. 12 divided by tangent 62. And I get 6.38 feet. Okay, so remember, over here, my ladder was at the very top of the wall, 12-foot wall, 13-foot ladder, and my distance away from the wall was 5 feet. If I slide this ladder further away from the wall to give me the 6.38 feet, that means that the top of this ladder is going to slide down the wall. So the ladder is simply not long enough. So, is it possible to adjust the ladder to a safe angle? No. The ladder is too short. Okay, so that wraps it up for Unit 4, Lesson 9. And hopefully you guys won't have much trouble. If you have any trouble, make sure you give us a contact. All right, take care.